In the previous video, we were discussing about regression testing, right? So we know what exactly the system testing is, integration testing is, as well as acceptance testing is. What exactly the acceptance test is, right? So we were discussing regarding regression testing, right? Regression testing, you always think that it is some kind of retesting in the sense, if you, for example, a code is there, any programming code, if you feel that you need to change that code, if you need to add some functionality to the code, or if you want to remove something from the code, if you made any changes to the code, then it's necessary to conduct a test to ensure that that code is still works after the changes has been made, right? So whatever the test you are going to conduct after changing that code, that is called regression test. So regression test always ensures you that after changing the code, still the code is actually working. If it is not working, then you need to make other changes so that the program should work, right? That is nothing but regression testing, right? So here also we have different selection criteria are there regarding different selection techniques are there regarding regression test. So let us concentrate on those techniques. The basic idea of this one, why we need different selection techniques for regression testing, is executing all test cases for large software products may require many hours or days of execution, of course, right? If your program code or if your product is very large, in the sense, if you want to execute all the test cases for a complete product, it requires many hours, right? Many hours, as well as, even though it requires many days of execution, and may depend on scarce resources. Of course, it depends on the resources also, such as an expensive hardware test harness, right? If your code requires to execute under expensive hardware test harness, of course you need to execute the code. It requires many days of execution, as well as many hours of execution, right? If you want to execute all the test cases, so there should be some way so that will ensure that you should complete all your testing within some certain time. So this test case prioritization orders frequency of test case execution, executing all of them eventually, but reducing the frequency of those least likely to reveal faults by some criterion, right? If you want to execute all the test cases, okay, fine, but it requires many days of effort, right? If you want to execute all the test cases within a short period of time, you need to follow some criteria. What was the criteria? For example, a test case is there. Product execution is there. If you want to execute all the test cases, there is not necessary to execute all the test cases. If the test cases which are actually exhibits or which are actually reveals the errors, that is more than enough to execute the test cases, right? I mean to say, if some test cases are there, that is guarantee you that definitely ensure you that it will reveal some error. If some errors are present in your code, that test cases definitely ensure you that it will definitely identify or detect those kind of errors. Then it is, of course, necessary to execute those kind of test cases. If test cases are actually no need to execute, or if some test cases not able to detect the code, detect the errors on the code, then there is no need to execute those kind of test cases. That is the basic idea, right? And also we need to reduce the frequency of execution, right? There are different kinds of execution, and different kinds of techniques are there for that one. We have a code based selection techniques, which actually selects a test case for execution if it accesses a portion of the code that has been modified. And another one is specification based criteria. It actually selects the test cases for execution if it is relevant to a portion of specification that has been changed, okay? So code base, in the sense, simply if I gives you what a meaning of code base, in the sense, it is related to the test cases It actually covers or covers exercises covers a portion of the code that has been modified. For example, a program is there, only some function has been modified in that particular program, then that particular function only need to be executed. That means the test cases which are related to that particular for portions ones need to be executed. That is the basic idea of code-based selection. No need to execute complete program, only need to execute the code where you have made some changes to the particular code. Okay, that is basic idea of code based selection. Whereas specification based criteria selects the test cases for execution if it is relevant to a portion of the specification that has been changed. So if it's related to code change, then it is called code based selection. For example, in initial requirement specification only, if you made some changes to the specification and if you execute the code related to that particular changed specification, that is called specification based criteria. Okay, there are actually mainly two selection based criteria is there. One is code based, another one is specification based. So when they ask for exam, you need to write both this one. Another general thing is that I will also explain that in the next slides. So what is code based? I already told you, right? So observation in the sense a test case code it doesn't execute. I mean to say, uh, for example, here they have complete test cases, right? In the figure they have given one figure where uh, colored portion is called changed portion. Or if you added some code to that one, or if you made any changes that correspond to this colored yellow colored box, so that is actually changed portions. Another uh, co- another area apart from that one is considered as a test cases, normal test cases. So there is no need to execute normal test cases, only need to execute the test cases for the colored portion here. So that is the idea of code based regression testing selection. Okay, that's why they have mentioned here in the large system many portions, that is actually portion many portions untouched by many test cases, right? That's why only few portions are only executed, that is colored portion only executed, that is actually changes. If you add some code or if you made any changes that any changes to the particular code, that only needs to be executed. That is the basic idea of code based regression test selection. So another one general portion is there, that is control flow and data flow regression test selection. General idea of that one. It is also same as code based selection only, but they have you know use some modified version of that code base. So this rerun test case only if they include changed elements. Of course, same as the code base that one. Elements may be modified, control flow nodes and edges and definition use based in data flow. So we know that the data flow testing. In data flow testing, we have some graphs, right? The definition use path graph or some nodes will come, some flow control flow nodes will come, right? So this is only related to that portion only. So if you need to know the difference between code based as well as control flow data flow graph, the code base only we are concentrating on the code base, where in this one, especially control flow data flow graph, we are actually concentrate on the graph data. For example, definition use pair, where exactly we made changes in defining the node or defining some variables or using this using those variables and all. It is related to this one control flow and data flow regression testing. To especially to select, why we need to automate the selection, tools record elements touched by each test cases stored in database of regression test cases. Tools note changes in the program, of course. Check test case database for overlap. Okay, these are all some criteria we are actually involves in the control flow as well as data flow regression test selection. So last one is specification based, right? Specification based, people, right? If you in initial requirement specification, if you added some specification to your document, or if you remove some specification, you need to execute the test cases for those portions only. That is called specification based regression testing. So like code based and structural regression test case selection, same way, but we are concentrating on the Selection, I mean specification. Pick test cases that test new or changes functionality. So specification in the sense, of course, the initial functionality we actually mentioned in the requirement and specification document. So what is the difference? Here there is no guarantee of independence since it is depends on the specification. You can't say it is actually independent, right? There is no guarantee for the independence here. A test case that is not for changer or added feature X might find a bug in feature X anyway. Of course, if you added new feature, some call X is considered as a new feature, you may find some bug in that particular feature only. That's why there is no guarantee for independence here. So what is the approach we actually follow here? So prioritization approach we are going to follow here. Execute all test cases, but start with those that related to change and added feature. Of course, same way. What is the added specification or the added feature, that only we are going to concentrate. Right. This is regarding the regression test selection uh, criteria. Right. So some priority we are going to give while selecting the test cases, especially in the regression testing, is actually based on rotating scheme, right? Here the basic idea is to execute all test cases eventually and execute some sooner than others. You may approach follow the same no, anyway two approaches here, but here execute all cases eventually. Of course, you need to execute all cases, but you need to give some priority to some test cases. So, what kind of priority you need to give? Let us discuss now. Possible priority schemes. First one is round robin. Okay, here in the round robin, priority to least recently run test cases. So those test cases will actually run recently, means the least recently. They only need to execute first. For example, if you frequently execute some kind of some portion of test cases, so you can postpone that one. Those test cases which actually run list, means which actually not run as frequently, then you can take those kind of those portion of test cases and you can execute that portion in the round robin fashion. So track record, priority to test cases that have detected faults before. They probably execute code with a high fault density based on the fault. For example, as I already said, those test cases which actually reveal or detect faults more frequently, those actually have given higher priority than others based on the fault. Last one is based on structural thing. So priority for executing elements that have not been recently executed, of course, based on the elements, based on some portion like course grain, feature, methods, files, and all. Those portion, those elements which actually not been executed recently, they have taken up and they can be executed. Okay, that is based on different priority. Based on round robin, like least run test cases can be given more priority. Based on track record in the sense fault. Okay, those who have revealed more fault, they have given high priority. Last one regarding elements execution. Those elements or files or methods which actually not been executed recently, they have taken up and they can execute it. These are all different kind of priority based on selection. Same way, this is actually definition version of the previous slide. Test case prioritization and selective execution, same thing, right? uh, of course, regression testing criteria may select a large portion of test suite. When a regression test suite is too large, we must further reduce the set of test cases to be executed. So it is actually same slide. The previous slide you have seen, actually have taken that slide from different net actually. So I have made that uh, you know in a point wise manner what exactly that tells you. Same idea they have given in the form of definition only, in the form of points wise. Okay, so random sampling is a simple way to reduce the size of regression test cases shoot. Okay, you can also use random sampling. So better approaches prioritize test cases to reflect their predicted usefulness. In a continuous cycle of retesting as the product evolves, higher priority test cases are selected more than the lower priority test cases. With a good selection strategy, all test cases are executed sooner or later, but the varying periods result in an efficient rotation in which the cases most likely to reveal faults are executed most frequently. Same, right? Which I actually, in the previous slide, what I explained, it's same idea. It is actually been conveyed here. Okay. So same way, based on execution history, so different approaches in the form of point by a selection based on execution history. A simple priority scheme assigns priority according to the execution history. Recently executed test cases are given lower priority, of course, while test cases that have not been recently executed are given higher priority. Selection based on fault detection. Right? Test cases that have revealed fault in recent position are given high priority. Selection based on structure priority. We can give high priority to test cases that execute elements that have not recently been executed. The same portion means same idea which actually present in the slide is given in point wise, in sentence wise. Same idea it's been conveying here. Okay. So while writing the exam, you should follow this approach, this slide approach. Okay. Test case prioritization aside to execution. Right? Why we need to prioritize the test cases. So the idea is to no, so if you need to execute all the test cases, it is actually time consuming. So we need to give more priority to some test cases. So to give priority, we are actually following three approaches. One is based on the execution history. We are giving higher priority to those test cases which actually not been run recently. Second approach is based on fault detection. Third approach is based on structural priority. Structural priority in the sense elements elements which actually executed start executed recently. Elements in the sense maybe function, maybe portion of a code, anything. Okay. Uh, so in the next video we will going to discuss regarding levels of testing. Okay, what is actually levels of testing as well as integration testing and all. Okay, thank you.